This is a question based around atomic structure. We've got a number of stages. I'm going to recommend you try each of those first, and then once you've had a go, review the answers. So it goes as far as part D. Here's A and B. Part C. And part D. Okay, I'm going to jump straight in with the electron configurations. Now, you will notice here I haven't answered them properly yet. I've given the electron configuration for the atoms. However, Cl- gains an electron, so the P5 is wrong. And Fe2 plus has lost 2 electrons, and you will always lose 4s before you lose 3d. So the actual answers come out as this. Chloride, 1s2, 2s2, 2p6, 3s2, 3p6. The iron, you don't have to include the 4s0, but depending on how you work your way through the question, sometimes people find it easier to include it. When it gets to the next question, read it very carefully. It wants the third ionization energy. So first ionization energy would go Mn to Mn+, second plus to 2+, third takes you from 2+ to 3+. If you do it Mn to Mn3+ plus 3e-, that's the combination of first, second, and third ionization energies. I still don't have the mark yet because the definition very clearly states that the state symbols must be gaseous. It's 1 mole of gaseous ions with a +2 charge loses 1 mole of electrons to form 1 mole of gaseous ions with a +3 charge, would be the definition for second ionization enthalpy. Moving on to part C, which of these has the lower first ionization energy with an explanation? I would always recommend that you write out the 2 electron configurations. The minute you do that, you can compare where the electrons are being lost from. And in this case, magnesium is being lost from 3s, but aluminium is being removed from 3p. So in aluminium, the outer electron is being removed from a higher energy p sublevel, specifically the 3p sublevel, and therefore it's easier to remove. Moving on to the final part, part D, you were asked for the symbol of the ion that would reach the detector first, so the one that's fastest. Well, we know that it's nickel because these are isotopes of nickel. We also know that in the acceleration phase, all of the ions are accelerated to have the same kinetic energy. Now that means that smaller ions with the same kinetic energy will move faster and reach the detector first. So it's nickel 58. Don't fall at the final hurdle. Remember that these are ions, so we need to include the +1. In terms of the calculation, it's a relatively straightforward one. You can see the working out here. And then again, the big pitfall here that people might fall into is to do all of that hard work, do the calculation, and then ignore the fact that the answer is to 1 decimal place. So we were looking for 58.9.